All right, this is 8th grade, lesson 11 for module 4. We're going to talk about constant rate. So we're going to continue kind of what we were doing yesterday when we found the constant rate, and now we're going to start applying it toward graphing as well. So let's get started. Pauline mows a lawn at a constant rate. Suppose she mows a 35 square foot lawn in 2.5 minutes. What area in square feet can she mow in 10 minutes? And we're going to use T for minutes. All right, so we're going to set this up like a proportion. Again, we know she can do 35 and 2.5, so let's put 35 with 2.5 as a comparison. Now we don't know the amount of square feet she can mow, so we're going to put that as an X or T, whichever you want to do, and we're going to solve for the 10 minutes. So if we gave her 10 minutes, how much could she mow? Because in 2.5 minutes, she can do 35 square foot. So let's see where we can get in 10 minutes. So again, just like we did on the previous lesson, we're going to cross multiply. So we get 2.5 times X gives me 2.5 X, and we're going to do 35 times 10, which gives me 350. Now this is asking me 2.5 times what gives me 350. If you're not sure, you just divide. What you do to one side, you do to the other. These here are going to cancel, and 350 divided by 2.5 is going to give me 140 square feet that she can mow. All right, so now we're going to come down here and fill in this table that relates to this same question, and then we're going to graph it as well. So let me get a different color here. We're going to use the equation of her 35 minutes in 2.5, or 35 square feet in 2.5 minutes. So we're going to set this to y equals 35. There you go. My pen wasn't working for a second there. And 2.5, and then we're going to multiply that by x. Now, I'm just going to pick some easy numbers. You don't have to make this very hard, all right? So I'm going to pick my time numbers real quick here. I'm going to say, what if we gave her no time? How about 1 minute, 2 minutes, 3 minutes, 4 minutes? And again, we're just making this simple. You don't need to make very large number because then you wind up graphing some very large graphs, okay? So what I'm going to do is I'm going to take this number here and I'm going to plug it in for the value of x and solve for the y. So again, this is my x and this is my y. So this is going to be y equals 35 over 2.5 times 0. And I'm just going to write these real quick so they're all written down. Y equals 35 divided by 2.5 times 1. Y equals 35 divided by 2.5 times 2. Y equals 35 divided by 2.5 times 3. Y equals 35 divided by 2.5 times 4. All right, so at least now I know what I'm going to be doing each time. And what I'm going to do is use the side of my paper here for some little bit extra workspace. And I'm going to get my calculator out. So if you remember, you can use your calculator as long as you're able to show the work as well. So the first thing we want to do is go ahead and just divide that 35 divided by 2.5. It's going to give me 14. So if you think of it this way, since those divide out as 14, then we just multiply that to the value of x, okay? So here we go. We have 35 over 2.5 times 0. Well, we know anything times 0 is just going to give me 0 anyways. Now we have 14 times 1 basically. So 14 times 1, 14. How about 14 times 2? 28. 14 times 3 is 42, and 14 times 4 is 56. And again, how I figured that out is I did 35 and I divided that by 2.5 on the calculator, and that gave me 14. And since these all have the consistent comparison here, then I know they're all going to equal 14. And then I took 14 and I multiplied that by whatever that x value was. All right, so now we're going to graph. I'm going to move this up just a little bit here so I can see my graph a little better. All right, now again, in my class, you don't need to graph every single point. It's totally fine. As long as you can pick at least a good 3, then you're good. So we had that 0, 0. So I'm going to plug in 0, 0. We had 2 and 28. So I'm going to go 2, 28 is almost 30. And then I'm going to do my very last one, 4 and 56. So 4, 56 is just above that line there. Now, hopefully you guys have a ruler. I'm going to try and freehand it here. All right, make sure you guys use a ruler so you have nice straight lines. And there's your graph. So we solved it with an equation, a table, and a graph for this particular problem. All right, let's move on. Example 2. All right, example 2 says, water flows at a constant rate out of a faucet. Suppose the volume of the water that comes out in 3 minutes is 10.5 gallons. How many gallons of water come out of the faucet in t minutes? Now, I don't mind if you guys use a different variable than t. That's not a problem in my class. All right, so we do know it comes out. We have 3 minutes and 10.5. So it comes out 10.5 gallons in 3 minutes. And again, you want to keep your units the same on top. So this is gallons and this is minutes. So when I set up my comparison over here, I want to set it up with my gallon on top again and my minute on the bottom again. So I'm going to say this is going to be my water over my minutes. Now, I don't know any of these variables. They're 2 different variables. So what I'm going to do is cross multiply. Now, I'm going to call this one a W and I'm going to call this one an M just for the sake of having to write that out each time. So 3 times W gives me 3W. 10.5 times M gives me 10.5 M. Now, if you remember this from the previous lesson, then we're going to try and get this variable over here by itself. And in order to do that, I'm going to divide by 3. My 3's cancel, and my water equals 10.5 over 3 times the minutes. Now, again, we have some different variables going on here because they used V and T. You could have used Y and X. It doesn't really matter. Just to kind of help us all out here, this is my X column. Oh, let's get a different color there. This is my X column. This is my Y column. And again, if you want, you could say this is Y and then this is your X. Either one, as long as you know what you're solving for. So I'm going to go ahead and keep with my variables just because I already worked with those. So we have Y equals 10.5, make sure my decimal shows up there, divided by 3 times M. All right, so times the minutes or times your X. Now, they already gave us some numbers here, and I'm happy they used small numbers. So we're just going to write those in. W equals 10.5 divided by 3 times 0. W equals 10.5 divided by 3 times 1. W equals 10.5 divided by 3 times 2. W equals 10.5 divided by 3 times 3. And W equals 10.5 divided by 3 times 4. So now that it's all written down, I can just go ahead and solve. Now, you are allowed to use calculators. So what I would recommend doing is find out on your calculator what your comparison here divides out to. So 10.5 divided by 3 is 3.5. So what we did is we did 10.5 and we divided that by 3 just to find out what that unit itself is. So I don't have to do that every single time. So now we're going to do 3.5 times these numbers here, and that'll give me my y's. So I'm going to come over here. We're going to say for the first one, we have 0, which we all know is going to be 0, so I don't need to use the calculator for that one. And just to show you how to use the calculator, I'll use that for a couple of these, but I think with the times 1, 3.5 times 1 is going to give me 3.5. All right, now for times 2. So 3.5 times 2 gives me 7. All right, let's do the next one. 3.5 times 3 gives me 10.5. And finally, the last one, 3.5 times 4 gives me 14. All right, and just like the last problem, you're going to go ahead and graph this. You do not need to graph every single dot, but you do need at least 3 to form that straight line. So I'm going to pick the easiest one there of 0, 0. Let me see. I have 2, 7. I like 2, 7 because it's not a decimal and I don't have to kind of guess where it goes. So that one lands perfectly on a point. And I'm going to do that last one, 4, 14. So 4, 14, right about there. All right, now you guys grab a ruler. I'm going to try and freehand this as best I can. Not too good there, but close enough for not having a ruler and writing on a tablet. So you guys grab your ruler, make that nice and straight. All right, let's move on to exercises. Juan types at a constant rate. He can type a full page of text in 3.5 minutes. We want to know how many pages Juan can type in so many minutes. So we're going to write our linear equation. So I know he can type 1 full page. So that's 1 full page. So we're going to use the number 1 for that to represent a full page in 3.5 minutes. And I'm going to go ahead and transfer that to a decimal for right now. So this is 1 over 3.5. Now, I want to know how many pages can he do in t minutes time. All right. So just like we did before, we're going to cross multiply. 3.5 times p is going to give me 3.5p. And then this is going to be 1 times t, which we're just going to say is 1t for right now. I know we don't typically write the 1, but just for right now, I'm writing it so you understand where I got that, where the 1 went and where I got the t from. Now, we're going to go ahead and divide this out because I want that p to be by itself. These cancel, and so the number of pages is equal to the time divided by 3.5. So that's going to be my equation. Now again, this is your x, this is your y. If you really wanted to, you could make this your y and that your x just to make life a little bit more simple. All right, so here we go. They already gave us our time, so I'm just going to go ahead and fill in my equations. So 0 divided by 3.5, I'm just plugging that 0 in for the time. P equals 5 divided by 3.5. P equals 10 divided by 3.5. P equals 15 divided by 3.5. And P equals 20 divided by 3.5. And again, you guys can use your calculators if it makes it a little easier. All right, so let's do the first one we can definitely do by itself. Dividing by 0 is just going to give you 0. All right, now by 5. So we're going to say 5 divided by 3.5 equals 1.428, this huge long thing. Okay, I like to say give me 2 numbers after the decimal, but in this case, because we're going to be graphing on a coordinate plane, I would just stick with 1 number after the decimal. The 2 does not round that 4, so we're just going to keep it at 1.4. All right, let's do the next one. We have 10 divided by 3.5, and I get this long decimal again. Now, the 5 is big enough to change that 8, so I'm going to change this to 2.9. All right, next one we have 15 divided by 3.5. Again, that 8 is big enough to change that 2, so we're going to make it 4.3. And lastly, we have 20 divided by 3.5, and that 1 is not large enough to change that 7, so it's going to remain 5.7. So now we're going to graph. Let me scroll this down just a little bit so I can see it better. We're going to go ahead and graph these. And again, you don't need to graph them all, but I do have a 0, 0. And I'm going to try graphing the 10 and the 2.9 just because 2.9 is so close to 3. I can almost get away with actually getting close to that 3. And then I'm going to graph that very last one of 20 and 5.7. So that's probably right about here, a little bit over half. You guys grab a ruler, make your lines nice and straight, and I didn't hit either dot, but in that sense, there's my line. All right, now this one. About how long would it take one to type a 5-page paper? So 5-page paper, if you remember back in our table, if you look back at your table, 5 pages, well, he did 20 minutes, took him 5.7. So if you remember, 20 minutes was 5.7 pages. And then we went right above it, we did 15, and that was 4.3. So I would say it would fall between these two times. So we're just going to say between 15 to 20 minutes. And the reason I'm not finding a complete answer is because it says about how long. So they kind of want you to guess. It doesn't have to be an exact number. All right, number 2. Emily paints at a constant rate. She can paint 32 square feet in 5 minutes. What area, A, in square feet can she paint for T minutes? Write the linear equation in 2 variables that represents the number of square feet Emily can paint in any given interval. All right, so let's go ahead and write our equation here. We do know that she can do 32 in 5. So 32 in 5, and then I'm going to switch out my colors here. This is your square feet, and this is your minutes. So again, you want to keep that consistent. So I want my square feet on top here, and I want my minutes on bottom here. All right, now it did say what is the area, or A, for square feet. So we're going to use A here because they asked us to. Can she do in T minutes? So there's your 2 variables. So now we're going to go ahead and cross multiply these to get our equation. So I'm going to say 5 times A gives me 5A. 32 times T gives me 32T. I'm going to divide out that 5 to get the A by itself because I need at least one of these variables to be alone. And I wind up with A equals 32 divided by 5 times T. And that's going to be my equation I'm going to use here. All right, now they already gave me my time, so I'm just going to go ahead and fill that in for all my T's. So A equals 32 divided by 5 times 0. A equals 32 divided by 5 times 1. A equals 32 divided by 5 times 2. A equals 32 divided by 5 times 3. And A equals 32 divided by 5 times 4. Now, I know that this one here is going to be 0 because anything times 0 is 0. But let's go ahead and grab our calculator just to make life a little bit easier. I want to find out what is 32 divided by 5 come out to. So I'm going to say 32 divided by 5 gives me 6.4. So this way I don't have to keep dividing that out each and every time. I can just say 6.4, and I'm going to multiply that by all my t values. So 6.4 times 1 is going to give me 6.4. 6.4 times 2, so we're going to times this by 2, and I get 12.8. All right, 6.4 times 3 gives me 19.2. And then finally, 6.4 times 4 would give you 25.6. All right, let's go ahead and move on to the next one. And that is graphing that. All right, so let me clear my screen there. Now again, you don't need to pick all of them. We're just going to pick a couple. All right, so I'm going to definitely get my 0, 0 in there. And then I'm going to do the 1. I have to look back at my problem here. 1 and 6.4, because that's kind of close to that 6. I can almost make it right there. And then I'm going to do my 2 and 12.8. All right, so that gives me 3. You could do the very last one if you wanted. Grab a ruler, make it nice and straight, take it all the way out, give it an arrow, and hopefully yours looks a lot better. Now it says, about how many square feet can Emily paint in 2.5 minutes? All right, so if you remember, with our last one, for 2.5 minutes, she did, at 2 minutes, she did 12.8 square feet. In 3 minutes, she did 19.2. So 2.5 is going to be right here in the middle of this. So we're going to say between 12.8 through 19.2 square feet. She can paint anywhere in between there in about that 2.5 minute mark. All right, number 3. Joseph walks at a constant speed. He walked to the store that is 1/2 mile away in 6 minutes. How many miles, M, can he walk in t minutes? Write your linear equation with your 2 variables. All right, so I'm going to write down what I do know. I have half, so I'm going to represent that by 0.5 in 6 minutes. So there's my 2 informational pieces I need. So 0.5 over 6. And again, I want my miles on top because I have half a mile, so I need the mile over here. And they want me to use M for that. And then my time, 6 minutes, is down here, and they want me to use T. So now we're going to do our cross multiply, and I get 6M equals 0.5T. Again, I want that variable by itself, so I need to get rid of that 6. And my final equation is M equals 0.5 over 6 times T. So that's going to be the equation I use for solving out my table. Okay, so here's my table. I'm going to go ahead and write my equation we just solved. So we have M equals 0.5 over 6 times T. Now I'm going to go ahead and plug in all my T's. So I have M equals 0.5 over 6 times 0. M equals 0.5 over 6 times 30. M equals 0.5 over 6 times 60. M equals 0.5 over 6 times 90. And M equals 0.5 over 6 times 120. Now, there's something I notice here with this particular problem is the values they chose for minutes here are multiples of 6. So instead of dividing this out on a calculator, which, by the way, I'll show you here and you'll see why I'm doing it this way. If I did 0.5 divided by 6, I get this crazy decimal. Now, because it's a repeat decimal, it's going to give me fractional miles, which is fine, but it's going to be very hard to get a completely accurate answer using a calculator. So what we're going to do is I'm going to show you how to do the cancellation method, or simplified method. So we do know that anything times 0 is 0, so we're just going to leave that one there. But if I write this one here, I'm going to write the 30. I have 0.5 divided by 6 times 30. Now, can 6 go into 30? Yes, it can go in 5 times. So now on my calculator, I'm going to do 0.5 times 5, and I get 2.5. Now I don't have to worry about that long repeat decimal. All right, now let's do the next one. I know that 6 can go into 60 10 times, and so I wind up with 0.5 times 10, which is just a decimal move, gives me 5. Okay, let's do the next one. 6 into 90. Now let's just imagine you didn't know and you needed to use your calculator. That's no problem. You just say 90 divided by 6, and that gives me 15. Now I'm going to do 15 times 0.5, and that gives me 7.5. So that's how you use your calculator to help you in these types of problems. You have to make sure you're using the calculator correctly. All right. And then we have 6 goes into 120 20 times. So on our calculator, we're going to say 0.5 times 20 is going to give me 10. All right. Now we're going to graph this out, but I'm going to go ahead and let you graph it since I've done several of those for you, and I'm going to move on to the next question. So if you need to pause the video, go ahead and pause. All right, the last question here. Joseph's friend lives 4 miles away from him. About how long would it take Joseph to walk to his friend's house? So, if Joseph's friend lives 4 miles away from him, and we look at our chart or our equation here, says that he can walk a half mile in 6 minutes. So you remember, he can walk that half mile in 6 minutes. Well, if his friend lives about 4 miles away, how long would that take him? All right, so let's solve that out. I'm going to do the x first, so I get 0.5x equals, and then 6 times 4 is 24. I'm going to divide this in half. So if you're using your calculator, just to show you your calculating skills here, we're going to say 24 divided by 0.5, and I get 48, 48 minutes. Let me get my pen here. So 48 minutes, and it wants to know about how long. So we're going to kind of round this. I would say 40 minutes is about an hour, give or take. All right. And that is the last problem for this lesson.